Good morning, my dear children. Today we continue our discussion on last year Keam paper in physics. Today we selected question from our unit 5, which includes field, electric field, potential and capacitors, Ohm's law. ഈ 3 ചാപ്റ്ററാണ് യൂണിറ്റ് 5 നമ്മൾ ഉൾക്കൊള്ളിച്ചിട്ടുള്ളത്. ഒന്ന് ചാർജ് ആൻഡ് ഫീൽഡ്, ദെൻ പിന്നെ നമ്മുടെ അടുത്ത ചാപ്റ്ററായ പൊട്ടൻഷ്യൽ ആൻഡ് കപ്പാസിറ്റർ, ദെൻ ഓംസ് ലോ. We can very well start with the question. The very first question is there on the board. The equipotential surface. Equipotential surface means potential is the same at all points. If it is a line, equipotential line. If it is a collection of lines, which means a surface, then it is called equipotential surface. And the property of the equipotential surface, you know. What is the work done to move a charge from one point to another on the same equipotential surface? 0. And that is a metal surface on charging, equipotential surface. Now here the question is not that. Equipotential surface is what the shape of equipotential surface. Now a plane for a point charge. If you consider a point charge, then the potential due to a point charge is given by 1 by 4 pi epsilon q by r. Therefore, at a distance r, if we imagine a sphere, the radius r, the potential at all the points on the surface of the sphere is the same. Therefore, in the case of a point charge, the equipotential surface is spherical. Spherical for a dipole is not so. It is not at all so. Cylindrical dipole, cylinder dipole, no. Then spherical for a point charge. It is spherical in the case of point charge. We shall go to our next question. The electric field intensity due to ideal dipole at a distance r from its center on axial line is directly proportional. Makes the relation that you derived there in your classes. That what is the field along the axis of a dipole, axial point as well as equatorial point, and the relation between them all known to us. Equidistant point along the axial line and the equidistant point on the equatorial line, the ratio is equal to 2:1, etc. Here it is not that data is required. Here what is the relationship of intensity at any point along the axial line of a dipole. Suppose this is the dipole and this is the direction of the dipole, positive charge, negative charge. Then at any point at a distance r, the electric field intensity formula is given by 1 by 4 pi epsilon 0 2p by r cube. That is the expression for electric field intensity. Here the dependence of electric field intensity on r proportional to 1 by r cube, and there 1 by r cube. So option is C. The option is A. Now next question. Two spheres A and B having respective charges 6 coulomb and 12 coulomb placed at a distance d repel each other because they are identical charges, both positive, repulsion. Difference rule. Like charge repel, unlike charge attract. Here it is repulsion and magnitude is given as F. The charge given to the sphere A to reverse the force as minus F. Now, this is A and this is B at a distance. What are the charges? On A, 6 coulomb and another one 12. 6 coulomb and here is 12. Repulsion is there. Repulsion 1 by 4 pi epsilon 0 q1 q2 by. And that is the repulsion force. by 4 pi epsilon 0, Q1, Q2 by R square. Where are the separation between them? Here, since they are like between them, there is a repulsive force. And what is the question is? Question says the charge given to A. Now I have to give additional charge to A. So this plus A must be minus A. Now this force become magnitude same, then the charge of A must be the same, magnitude wise. But it is said that is minus A. So repulsion. That means this plus 6 must be changed into minus 6. That's it. This plus 6 must be changed into minus 6 coulomb. Then between the magnitude is same, but the repulsive attractive force. Attractive force. Repulsion is positive, attraction is negative. It's okay. So it become negative, minus 6. Now plus 6 become minus 6. For which how much additional charge we have to give to A? Definitely is minus 12. It is equal to minus 12. And 6 plus minus 12 is equal to minus 6. This is the additional charge that you have to give is equal to minus 12 coulomb. That is there, minus 12 coulomb. We shall go to our next question. The work done. The work done by a source in taking a unit charge from lower to higher potential energy is called source, as far as source is concerned. What is source is doing? Source is converting any other form of energy into electric energy. That is an electrical source. And there you may remember the word that we use is called EMF. EMF is work per charge. Work per charge. Whatever may be. In a chemical cell, it is the chemical energy. In a secondary or primary cell, chemical energy can convert into electric energy. But the potential difference, PD is the electrical work per charge, whereas EMF is work per charge. Here, the answer is that it is that the work done by a source, here the electrical source, taking a unit charge from one point to the another, is called its electromotive force, EMF. So, option is from very definition, it is electromotive force. Whereas potential difference is the electrical work per charge, for a charge from one point to another. It is the electrical work. In a cell, what it is doing? In a cell, it is transferring the charge from, it is said that there is the work done taking a unit charge from lower to higher. Lower to higher. Then higher to lower to flow through the conductor generated current. Lower to higher, that is what is called electromotive force. Okay. We shall go to our next question. In a Western network, ABCDA, 20 ohm, 10 ohm, 12 ohm, in AB, BC and DA arm respectively, in which galvanometer is connected across PD. For null deflection in the galvanometer resistance in the CD arm. So we have to draw that ABCD. So this is A, B, C, D. Now this is one arm, another arm. And galvanometer is connected between B and D as per the problem. And EMF is applied between A and C automatically. Now what is the question? And the resistance in each arm that is given to you. AB 20, AB, this is 20 ohm. BC 10 ohm. And DA is 12 ohm. Now question is what is the resistance here? So that the bridge is balanced. Now for balancing condition, even in the case of a piston bridge, the ratio of the respective arm, every arm must be say P by Q is equal to R by X. Therefore you can write 20 by 10, so 12 by this value, suppose I say x, from this x is equal to this will cancel out, x is equal to 12 by 2, 6. So our answer is 6. The condition for balancing of a Wheaton's bridge that we applied there. Next question. The product of total electrical flux emanating from a closed surface enclosing a charge q in free space. Epsilon 0 is the electrical permittivity of free space. Now the question, there is no meaning in asking about the product of total electrical flux. Product of electric flux with what? Not stated. What they mean is the total electrical flux. And that is by Gauss's theorem, you know. Suppose we have got a closed surface, what may be the shape? A closed surface, what may be the shape? If encloses a net charge q, the total electrical flux emerging from this surface is given by Gauss's theorem, 1 by epsilon 0 times q. But due to mistake, but in the question there is the product of flux with the one that is not stated. And therefore the question has no meaning and therefore it was deleted. But what they mean, I think, the total, this word if you neglect, then the total electrical flux emanating from a closed which encloses a charge q by Gauss's theorem is equal to 1 by epsilon 0 times q. That is the box. If this is not there, the answer is. But that was there and therefore the question was deleted. Next question. Three capacitors, 1 mu amp, 4 mu amp and 5 mu amp are connected in parallel with the supply voltage. The source is the same and all are connected in parallel between the source. The total charge flowing through the capacitor is 50 microcoulomb. Then the supply voltage is. Now, here we know, if you draw the figure, this is 1 mu amp. This is our second capacitor and this is our third capacitor. All are connected between the same source. So the charging potential for all the capacitors are the same. And what is the magnitude of the capacity of each capacitor? Given that 1, 4 and 5. Yeah. And what is the total charge? Flowing through the capacitor? If the total charge flowing through all the capacitors is 50 microcoulomb, it is given. All these capacitors together store 50 microcoulomb. It is charge. Then the question is, then the supply voltage. What is the supply voltage? Charge is total charge. Now you know all these capacitors are connected in parallel. Therefore, its equivalent circuit if we draw, it is all the capacitors parallel. C1 plus C2 plus C3. A single capacitor, the capacity 10 mA. Connect across this source. And energy on this and energy on this one are the same, which is 50 microcoulomb. I'm sorry, energy and not energy is the charge. Charge on this combination is the charge on this equivalent circuit. And what is the charge? 50 microcoulomb. And what is the expression for charge? Charge is equal to CV. Now the total charge Q is equal to CV. Q is equal to 50 microcoulomb is equal to C 10 microfarad in the potential. Therefore, the common potential V is given by 50 by 10. 5. So the cell has got the voltage 5 volt. Here the answer is 5 volt. Option is. Okay, we shall go to our next question. The resistance of a wire at 0 degree centigrade is 4 ohm. The temperature coefficient of resistance of the material of the wire is equal to 5 into 10 raised to minus 3 per degree centigrade. Then the resistance of the wire at 50 degree centigrade is. Now, resistance of the conductor changes or increases with the temperature, and the relation formula that is known to RT is equal to R0 into 1 plus alpha t. Theta is theta, that's okay. R theta is equal to R0 into 1 plus alpha theta, where theta is in degree. Here, we are asked to find what is RT, resistance at a known temperature. Where R0 is the resistance 0 degree centigrade given to you. It is 4 ohm, 4 into 1 plus. The other one is alpha, the temperature coefficient of resistance, given to you as 5 into 10 raised to minus 3. 5 into 10 raised to minus 3. The temperature at which the resistance of the wire is asked, that is at 50 degrees centigrade. Now this is 4 into 1 plus 5 into 5, 25 into 10 raised to minus 2. It's equal to 4 into 1.2. It's equal to 5. So our answer is the resistance of the wire at 50 degrees centigrade is 5. So option is elephant. Remember, here the resistance 0 degree centigrade is given. Therefore, instead, they may give you the resistance at another known temperature, not at 0 degree. Instead, some other temperature, and the resistance asked for some other temperature. Known temperature resistance is given. For another known temperature, higher temperature, what is the resistance? Then you cannot directly apply this relation. In that case, you have to apply the relation. You may remember alpha is equal to R2 minus R1 by R1 T2 minus R2 T1. This is the relation. Because R0 and the resistance of the wire at 0 degree centigrade, resistance of the same wire at a higher temperature are widely different. And you cannot use this relation if R1 is given instead of R0. And if R0 is not given, but R1 some other known temperature. Since R1 is given, T1 is known. T2 is given, alpha is given, R2 can be calculated. In that case, you have to use this relation. Here R0 is given, therefore definitely you can simply apply this relation. Okay. And you got the answer. Shall we go to our next question? Yes. N number of electrons flowing in a copper wire for 1 minute constitute a current of 0.5 ampere. Twice the number of electrons flowing through the same wire for 20 seconds will constitute a current of. Now current is charge flowing per second, basic definition. And charge Q is equal to N into E. If N is the number of electrons, and his electronic charge Q is given by N into E. Flowing T. Therefore, current I is equal to charge. This is the basic formula we are applying. In our problem, it is given that N number of flowing 1 minute constitute a current of 0.5. But now, first case 0.5 is equal to N into E. The time is 1 minute. Is it so? For 1 minute. And there was 60 seconds. Question number 1. In second case, what current is asked? Why? I don't know. That is called Y dash, we can see. What about the number of electrons that is sent through in second case? It is that then flowing through the twice the number of electrons, twice, so 2n TPE by, and time of flow, not 1 minute, but only simply 20 seconds by 20. Question number 2 by question number 1 gives a dash by 0.5. I dash by 0.5 is equal to 2NE by 20 into 60 by NE. This will cancel out. This cancel out. This cancel out. This is 6. Therefore, I dash is equal to 6 into 0.5. Is equal to 3 ampere. So the answer is equal to 3 ampere. That is where option is box. Basic definition of current. That what we apply. Here it is electronic charge E. Now suppose it is a doubly ionized ion. It is equal to N into 2E. Because each ion carries 2 electronic charge. Magnitude. Triple ionized N into 3. Yes. Next one. We shall go to our next question. If a cell of 12 volt EMF delivers 2 ampere current in a circuit having a resistance 5.8, then the internal resistance, figure is like this. I want a cell and external resistance. And what are the values given to you? A cell of 12 volt. And this is called 5.8 ohm, I think. Having a resistance 5.8 ohm, and the current delivered is 2 ampere. So what is the internal resistance? Now we have to directly think about the current equation in terms of internal and external resistance. Current I is 1 by net EMF by total resistance R plus. Here I is equal to 2 ampere. EMF is equal to 12. External is 5.8 in plus into resistance R. Therefore, cross multiplying plus 2R is equal to 1. 2R is equal to 12 minus 11.6 is equal to 0.4. R is equal to 0.4 by 2. 0.2. So the internal resistance of the cell is equal to 0.2. It's equal to 0.2 box. Option is there. So okay. We shall go to our next question. It is if the electrical field intensity. Question realize this. If the electrical field intensity between the plate of a charged parallel plate capacitor, electrical energy stored per unit volume, permittivity of free space is equal to epsilon 0. For parallel plate capacitor, and you know that where the energy is there, energy is stored in the directed medium between the plates, where electrical field is there, and therefore the dipoles are arranged and possess electrical potential energy by rearrangement of the dipoles here. The energy not on the plate, but it is in the space between the plates, space between the plate here. And then the expression for energy density half, formula simply write down the formula. Energy density is given by half epsilon 0 square. The total energy by volume, that is what we did. Energy of a charging capacitor is equal to half CV square by volume is equal to A into D. Without simplification, you got this equation. This half epsilon 0 is square. Half epsilon 0 is square. Option is box. But this shows then all the formula must be there with us. നമുക്ക് നമ്മുടെ ഫോർമുല ബേസിക് റിലേഷൻസ് ആണ് ആ ഫോർമുലകളെല്ലാം അത് അറിഞ്ഞിരിക്കണം. Shall go to our next question. Two light charges kept in air medium Two like charges kept in an air medium experience a force F when they are separated by a certain distance R. When the same charges are kept in dielectric medium at the same distance of separation, the force between the physical 0.5 R was halved than the dielectric constant. You know, suppose the charges are Q1 and Q2 separated by distance. 1 by 4 pi epsilon 0 Q1 Q2 by R square. When it is filled with the medium of dielectric constant, the F in air, F in medium is given by epsilon 0 epsilon R Q1 Q2 by R square. Then dividing FA by F1. If you do, it's called epsilon R dielectric constant. So this is our relevant formula. FA by F1 is equal to epsilon R. In our problem, we are given both. What is the force? Force in air was F, whereas force in medium is equal to 0.5. So therefore, that is equal to F by 0.5. Sorry. F by F by 0.5 cancel out. So dielectric constant of the medium that is filled in is given by dielectric constant 2. So option is down. Option is down. Okay. Next question. The energy stored in the capacitor after closing the K key is given. Now figure shows directly a capacitor being charged by a cell of EMF E. And what is the electrical work done? Our electrical energy stored in the capacitor, half CV square. Energy stored in the capacitor is equal to half CV square. Answer, direct formula. Now what is the electrical energy expended by the cell? Suppose the question. Then this is equal to half EQ. Again, this is equal to half EQ. The electrical energy is stored. But where is the work done by electrical work done by the cell? Cell send QM to charge at a potential of EMF of V. What is the electrical work done by the cell is equal to VQ. Electrical energy stored and electrical energy expended. Stored in the capacitor and expended by the cell. And that is one of the beautiful questions. You can see that is equal to half. So whatever expended by the cell, half is stored in the capacitor, half is lost in the form of heat during charging. Question is not that. Question is simply what is the energy stored in the capacitor. That is equal to half CV square. Option is C. ഇതിൽ നിന്നൊക്കെ നിങ്ങൾക്ക് കാണാവുന്നത് മിക്കവാറും എല്ലാ ചോദ്യങ്ങളും നിങ്ങൾ പഠിച്ചിരിക്കേണ്ട ഫോർമുലകളുടെ ഡയറക്റ്റ് അപ്ലിക്കേഷനാണ്. അല്ലാതെ ലോജിക്കൽ കൺക്ലൂഷൻ അറൈവ് ചെയ്ത് ചെയ്യുന്ന പ്രോബ്ലങ്ങൾ ഒരെണ്ണം മറ്റൊക്കെ നമ്മൾ കണ്ടിട്ടുള്ളൂ. അത്രേ ഉള്ളൂ. അപ്പോൾ ബേസിക്കായിട്ടുള്ള ഫോർമുലകൾ പഠിക്കാൻ നമ്മൾ തയ്യാറായിരിക്കണം ഫ്രം ദി വെരി ബിഗിനിങ്. അടുത്ത ചോദ്യത്തിലേക്ക്. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. Masses of 3 copper wires are in the ratio 1:3:5 and their length are in the ratio 5:3:1. Then the ratio of the electrical resistance. Now the standard formula that we remember or that you studied or keep in mind is the expression for resistance in terms of length and radius or area. That is R is equal to rho L by A. And if R1 is to R2 is to R3 is asked, the material the same, rho is a constant, then L1, L2, L3 must be given. L1, A2, A3 must be given. Or radius at least. We are not given that. Instead, we are given the mass ratio, not radius ratio. Therefore, what is our duty? Our duty is to replace the unknown thing. Unknown term is the area. must be in terms of mass. Radius area mass നമ്മൾ മാറ്റണം. അപ്പോൾ ഏരിയ എഴുതേണ്ട മാസ് എഴുതിയാൽ mass is given, known quantity. അപ്പോൾ we have to transform this equation first. And what is the transformation? You know, mass of the body is equal to area cross section into length, volume into density. That is the material density. From this, you have to replace M by LT. That is the density material, mass density. That is substitute the R is equal to rho L by M by LT is equal to rho D L squared. Both are constants. Now, this is the formula for resistance in terms of length and mass. Both are given to you. Therefore, R1 is to R2 is to R3. Mean L1 squared by M1 is to L2 squared by M2 is to L3 squared by M3. L1, L2, L3 given to you, and M1, M2, M3 is given to you. Mass ratio 1 is to 3 is to 5, and the length ratio 5 is to 3 is to 1. This is equal to 5 squared, 5 is to 3. 3 squared, 1 squared. By what the mass corresponding mass? 1 is to 3 is to 5. 1, 3. So this is our ratio. Equal 25 by 1, 9 by 3 is to 3, 1 by 5. Take 5 as LCM, 125, 25, 15. So 125 is to 15 is to 1. So option C. So sometimes we have to do this. Some of the formula, standard formula that is there with us. അതുകൊണ്ട് ചിലപ്പോൾ നേരിട്ട് ഉപയോഗിക്കാൻ പറ്റില്ല. അപ്പോൾ പിന്നെ നമുക്ക് തന്ന ക്വാണ്ടിറ്റിയിലേക്ക് ആ ഫോർമുലേനെ ഒന്ന് ട്രാൻസ്ഫോം ചെയ്യണം. അത് നമ്മളിവിടെ ചെയ്ത് കണ്ടു. ഏരിയനെ മാസിലേക്ക് മാറ്റി. ചിലപ്പോൾ തരിക ലെങ്ത് തരും. അപ്പോൾ ഏരിയ മാസം നിന്നാലോ അപ്പോൾ there we have to replace the length in terms of mass. ശരി. So I'll go to our next question. Question is like this. Mobility mu of electron is related to average collision time. Now, what is mobility? Mobility is drift speed per unit electric field. Mobility mu is equal to Vd by drift velocity per unit electric field density. Vd by E is called the mobility mu. Where what is Vd? Vd in juice theory we studied is equal to E by M, acceleration into relaxation time 2 by this is the acceleration into relaxation time. That's the velocity gain, drift velocity by electric field. E, this will cancel out. So mu is equal to specific charge into relaxation time. E by M into 2. Simply write down that formula. And what is the option there? You can see that mu is equal to, now what is mu? E2 by M, yes. Dog option, E2 by M. Now next question. The electrical power delivered by a transmission cable of resistance RC. Cable transition cable has got resistance RC at a voltage V is P. The power dissipated in the cable. That's it. The power dissipated is. Now you know the basic definition of power P is equal to PI. Power P is equal to VI. And therefore, I is equal to P by V. The current in the device is given by P by V from this relation. P is equal to Vi. From this, I is equal to P by V. Now the question is heat generated, energy lost, the transmission power line. Energy loss in the transmission line is the copper loss or I squared R. About heat generated is equal to I squared R. Here I is given by P by V whole squared into R of cable. P squared by V squared into R. P squared into V squared. Oh, sorry. P squared RC by V squared. So option is 2. So that is the energy loss in the form of heat in the transmission line. Next question. A thin spherical shell question read like this. A thin spherical shell of radius 12 centimeter is charged as such that the potential on the surface is equal to 60 volt. Then the potential at the center of the sphere is. Now it is a thin spherical shell, conducting shell is charged. When a conducting shell is charged, whether it's solid or hollow, it is a shell and therefore it's hollow. But whether it's solid or hollow, charge will reside only on the surface. In the case of a hollow shell, charge resides only on the surface. And electric field intensity inside is 0 and therefore potential is everywhere is constant. Because E is equal to dV by dr. E is equal to minus dV by dr. Therefore, electric field intensity is 0, dV is equal to 0. Therefore, change in potential is 0. Therefore, if we consider 2 points, one is on the surface and other is nearby inside. What is the difference? Difference must be 0 because electric field intensity inside is 0. And therefore, dV 0 means potential here and here are the same. Here, everywhere is the same. The potential of, in our question, spherical shell, when it is charged, potential on the surface as well as potential at any point, including at the center, is same as on the surface. And what is the surface potential? 60 volt. The potential at the center is also 60 volt. So the answer is 60. Option is D. Clear? Shall go to our next question. It should be accelerated, so something wrong. The question is not completed. 24. Now you have to complete the question. It should be, we would have something to be added. It should be accelerated. It should be mean a stationary body of mass by gram carries a charge of 5 micromolar. The potential difference with which it should be accelerated. So this goes there. A question must be read like this. A stationary body of mass 5 gram carries a charge of 5 microcoulomb. the potential difference with which it should be accelerated to acquire a speed of 10 meters per second. Then only the question is complete. But this must be added with our question. Now, when a charged body in an electric field accelerated, it gives electrical work is done, and the electrical work done is given by VQ. Electrical work done is given by VQ. That electrical work done by work energy theorem accepted by our charged particle as its kinetic energy. Electrical work done is same as kinetic energy. Equity. So electrical kinetic energy half mv square. Gaining kinetic energy. The electrical work done is called VQ. And what is us? The potential difference with which should be accelerated. It is us. So V is us. Now everything else is gone. Therefore, half mass of the body is gone 5 gram. 5 into 10 raised to minus 3. The velocity equate 10 meters per second. 10 square is equal to potential between which accelerated we don't know. Into charge of the particle. That is given. Carries charge of 5 microcoulomb. 5 into 10 raised to minus 6. From this, V is equal to 10 raised to 5. This will cancel out. 10 raised to 5. Half into 10 raised to 5 is equal to 5 into 10 raised to 4 is equal to 50 into 10 raised to 3. 50 kilovolt. So the answer is equal to 50 kilovolt. Option is C. Electrical work done, work energy theorem is the kinetic energy. And what is the electrical work done is going by VQ. Kinetic energy is going by half mv square. Equate and get the answer. Okay, that's what we did. Shall we go to our next question? And electric dipole. An electric dipole of dipole moment P is kept in uniform electric field E, so that it is aligned parallel to the field. The energy required to rotate it through 45 degrees. Now, initial condition is that the dipole is along the direction of the field and it is in stable equilibrium. Stable equilibrium. Now, from there it is rotated through 45 degrees. What is the work done? We know the basic definition for work done or rotating a dipole from theta 1 to theta 2 is given by PE cos theta 1 minus cos theta 2. This is the expression for work done for rotating a dipole. Here we are rotating. This is the field and the dipole is along this direction. And therefore angle is 0. Our theta 1 is 0. Theta 2 is equal to 45 degrees. It is given. Rotated from there, it is rotated to 45. The work done is equal to P, dipole moment. P in the name of P. Electric field intensity E into cos 0 minus cos 45. It's equal to PE 1 minus 1 by root 2. It's equal to PE root 2 minus 1 by root 2. P root 2 minus 1 by root 2. So option is C. Option C. Next. A steady current of 2 ampere is flowing through a conductive wire. The number of electrons flowing per second in it. Repetition, we did just earlier. You know, current is charged by time and the charge is equal to N into E, electronic charge. N into E is equal to E into T. And what is the number of electrons flowing per second? So, N is given by current into time by electronic charge. Current through the circuit, 2 amperes. time 1 second by electronic charge. That on calculation is equal to 1 point, this is 10 raised to 19. So, okay, option is box. Option is box. Next. If the voltage across the bulb rated to 20 volt and 60 watt, above wattage and voltage are given, drop by 1.5 percentage. So here the power and voltage, power is the function and voltage is the variable. And one changes, the other changes. And therefore, what is the relationship between them? That you have to write. We know power, 1.5 voltage, complete the question. The percentage drop in the rated value of the power. When voltage drop by 1.5 percentage, what is the percentage drop in power? Suppose, and therefore what you have to write down? Since the variation is very low, 1.5 percentage, we can go to our first chapter. And percentage of error, relation between the function and variable can be applied. For which we have to write down. What is the relation connecting power and voltage? Because power is the function and variable is voltage. And in the problem it says that voltage drops by 1.5 percentage. So what is the power in terms of variable? P voltage, P is equal to V square by. So this is the function and this is the variable. And the variation in variable is 1.5, you can apply power rule. So what is the percentage of variation in power? Power times percentage of variation in voltage. It's equal to 2 into 1.5 is equal to 3%. So it is variable there 3%. We apply the power rule because the variation within permitted range. Maximum permitted range is 5%. Here is only 1.5. It's better apply this relation. Okay. You got the answer. Next question. The terminal potential difference of a cell in an open circuit is 2 volt. PED, terminal voltage. Potential PD is given 2 voltage. When the cell is connected to 10 ohm resistor, the inner resistance fall to, the terminal potential falls to 1.5 volt. The inner resistance of the cell is. Now, what we are given? We are given the terminal potential of a cell when it is open circuit. That is the EMF is good. 2 volt. But when it is load connected to a load, and what is the load there? Cell is on 10 ohm resistor. The terminal PD falls to. Now V is equal to 1.5. While discharging this, then what is the relation between V and E and the current? You know, during a discharging of a cell, V is equal to E minus I. Here, V is given 1.5, E is given 2 volt. And inner resistances are for which we must know what is I. Now, to calculate I, once this resistor is in circuit, the terminal PD 1.5 is drop across 10 volt. But PD drop across 10 ohm is equal to 1.5 volt. Therefore, current in the circuit, then current in the circuit is equal to PD drop by resistance. PD drop is 1.5. Resistance is 10. It's equal to 0.15 ampere. Now you got the current through the circuit. Then straight away go here. V is equal to 1.5 is equal to 2 minus I 0.14 into R. R is the internal resistance. So 0.15 R is equal to 2 minus 1.5 is equal to 0.5. That R is equal to 0.5 by 15. Sorry. 0.5 by 0.15. It's equal to 50 by 15. 10 by 3. So internal resistance is equal to 10 by 3 ohm. 10 by 3. Direct application of Ohm's law. Shall I go to our next question? The ratio of the magnitude of electrostatic force now the question is the ratio of magnitude of electrostatic force between electron and proton separated by a distance r to that between proton and alpha particle separated by same distance. When it was electron and proton charges are same. So you have proportional to Q1, Q2. Because all other terms are the same. That is one. The first case you have proportional to electron and proton 1:1. Second case you have dash proportional to. What are the charges involved? Charges involved would the second case proton and alpha particle. Proton charge 1, alpha particle 2. Equation number 1 is equation number 2. Basic equation F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. These are all constants. That is why now dividing 2 by 1 gives F dash by F is equal to I F dash is equal to F. 2:1. Option is done. If that is the order, F dash by F, it is equal to 2:1. Now, let me see the answer. 2:1 or 1:2. Order no. The ratio of the magnitude of electrostatic force between electron and proton. That is the first step. So, okay. Now, F by F dash that we required. F by F dash. The reciprocal is required, not this one. But the required is equal to equation number 1 by equation number 2 gives F by F dash is equal to 1 by 2. So the answer is 1:2, not dog. This is not the option. Option is. But you have to observe well what is the which ratio is asked. Here the correct option is equal to 1:2. Next question. The electric field due to an infinitely long thin wire with their linear charge density lambda, radial resistance R from proportional to. You know by the application of Gauss's theorem. Suppose we have a uniformly charged linear charge density lambda at a distance R. The electric field density is gone by 1 by 2 pi epsilon 0 lambda by or E proportional 1 by M. And that is what is asked. Oh, sorry, here lambda is also included. So lambda by. So E proportional to lambda by R. So option is. Again, directly they ask the formula. Write down the formula. Shall go to our next question. A spherical metal shell A of radius RA and a solid metal sphere B of radius RB, which is less than RA. Earlier was a shell, second one is a solid metal. Are kept them apart and each given the same charge plus Q. If they are connected by means of a thin metal wire, QA and QB, are the charge on A and B respectively, then what is the relation between? What is the relation? Equation, what is the relation? You know, first one is the spherical metal shell. This is a shell. A, R. Radius is A. And the other one is solid metal B. This is B, RB. Solid. Whether it is solid or hollow, once it is charged, the charge will reside only on the surface because it is the conductor, both of them. Charge reside only on the conductor. And the potential of this one in terms of that. Potential of this one is equal to VA. അത് വേണ്ട എന്നാലും പറയാം. നമ്മുടെ ഫോർമുല 1/4 charge given Q by RA. Whereas this one potential B is given by 1/4 charge Q by its radius RB. It is given that RA, let me see, RB less than RA or RA greater than RB. So this is more and therefore VA is less, but VB is more. Even though both of them are given same charge, their potential are not the same. This is the higher potential and this is the lower potential. And when they are connected by means of wire, definitely charge will flow. Till potentials are the same, not charge. Or there will be sharing of charge. From a body of a higher potential to lower potential. This is higher potential. Therefore, both of them initially possess QQ. Now, some charge will flow from here to here. Therefore, charge on this one decreases. QB decreases. QA increases. QA after sharing, QA greater than QB. In idellade വേറെ explanation നമുക്ക് പറയാം. No, both of them same charge. But a spherical body, capacity radius is a measure of capacity. So his radius is more. Our capacity of A is greater than capacity of B. Because capacity of a spherical body is given by 4/0 R. Here R more, R less. This is a larger capacity. Now when they are combined, the total charge QQ, both of them is 2Q, will be shared as per their capacity. Since the capacity, the one which has got larger capacity, will share more charge. And therefore I will have more charge and we have got less charge. There is another explanation. So again, the number of electrons whole pair per centimeter cube of an intrinsic silicon wafer temperature. Now, strictly speaking, this is question from semiconductor, but the question connected related with the Ohm's law or current density. Therefore, we can do here. Wafer at temperature 300 Kelvin is 1.1 into 10 raised to 10, and the mobilities of electron and hole at 300 Kelvin. 1500 and 500 per volt respectively. Then the conductivity of, now in a semiconductor, conductivity is contributed by two. Total conductivity is the conductivity due to electrons plus conductivity due to holes. Ne plus sigma E plus sigma H. Sigma total conductivity is the conductivity to both are charge carriers. Take part in conduction. Therefore, sigma E plus sigma H. What is the basic formula? Sigma E. Ne mu. Ne E. E into mu E. What is sigma H? From Dewey's theory. Charge carrier concentration. NH E. H. Here, Ne and is intrinsic. Therefore, Ne number electron hole pair are equal. Upon number density of electron and holes are the same. So Ne is equal to NH because it is intrinsic. E is the same charge per carrier is the same, and therefore what is sigma? Sigma is equal to, we get Ne or NH same, and therefore one of them is taken out and equal to error period N. But this is Ni, this is also Ni. Ni into E, mu E plus mu H, where mu is the mobility. Sigma is equal to Ni. Ni is given as 1.1 into 10 raised to 10. 1.1 into 10 raised to 10. 1.6 into 10 raised to minus 19. Into mu E, mu H, both given to you. 1500 500. 0.1 into 10 raised to 10 into 0.6 into 10 raised to minus 19 to 2000. The 10 raised to minus 60, minus 6. That is micro. The 10 raised to 4. Uh, 10 raised to 10 into 10 raised to 3, 10 raised to 13, 10 minus plus, the minus 10 raised to minus 6, that is equal to micro. Micro, that will go to micro term. The other term is equal to 1.6 into 2 into 1.1. That is equal to 3.52. That is on multiplication. That multiplication give you the answer 3.52. So this on multiplying 3.52 into 10 raised to minus 6. This is taken into micro. Therefore 3.52. So the answer. In semiconductor physics, you know, both charge carriers are there. Both take part in conduction. Next one. Magnitude of derivative velocity per unit delta field is known. Name. Derivative speed Vd by E is called mobility. Therefore, the option is mobility. Next question. The y-intercept of a graph between terminal voltage and load resistance are along y and x axis. Now, terminal PD on y axis and load on x axis, respectively, of a cell with the inner resistance are shown. We are given a figure. And what is the terminal PD equation? Terminal PD equation V is equal to E minus I into inner resistance R. Where R is the inner resistance. And we are going to draw a graph connecting y-intercept of the graph between terminal PD V and the load resistance R along Y. Load resistance along y-axis as cell with the inner resistance are shown in figure. Now, this is the equation where what is I? I is equal to I is equal to, we can say that E by R plus E plus R plus R. So, or V is equal to E by R plus R into R. V is equal to E by R plus R into R. And with whom you have to draw the graph as per question. Find the graph between the terminal voltage V, load resistance R along Y and X. So this is along Y and this term along capital R is along y-axis and x-axis. But definitely there is a mistake. Mistake is that with the load resistance R, instead of load resistance, because it is a somewhat a complex term. Here you can see it's a complex term. But what they mean, as per the question is, inter-resistance, small r. Inter-resistance, small r, what is the graph? Then this equation we know that y is equal to c minus mx. Definitely this graph is a straight line. And the y-intercept is equal to EMF. And the slope is negative, graph goes like this. So y-intercept is EMF. The question is, what is the question is y-intercept of the graph. The y-intercept of the graph is equal to EMF. EMF of the cell. The question here to be corrected, there is not a capital R, but the graph is between small r, not with the capital R. Capital R aitalla graph it between small r. Then the y-intercept is EMF, not with the load resistance. It's okay. Next question. When a glass rod is rubbed with the silk, when glass rod is rubbed with the silk thread, it loses 1000 electrons. That means glass rod loses 1000 electrons. Then the charge on the glass rod is, when it loses 1000 electrons, it gains the same amount of positive charge. Glass rod was electrically neutral, from which 1000 number of electrons left out. And therefore, residual charge is equal to positive charge due to 1000 number of electrons. Therefore, the charge is plus 1.6 into 10 raised to minus 19 into 1000. So plus 1.6 into 10 raised to minus 16. So it again a charge 1.6 into 10 raised to minus 16 coulomb. Option is C. Next question. In bringing a proton towards another proton, so the repulsion is there between them. The electrostatic potential energy of the system, definitely work is to be done to bring closer, and therefore potential energy increases. So therefore, oh no, sorry. So go to next question. In bringing a proton towards another proton, the electrostatic potential energy of the system, when they are brought closer, work is to be done, and that will be accepted as its increase in electrical potential energy. Therefore, the energy increases. So option is equal to box. Next question. A parallel plate capacitor with the dielectric medium of dielectric constant 1.5 has got a capacity C. With the dielectric constant, capacity is C. If the dielectric removed, then capacitance of the capacitor. Now, if C dash is the capacity of air core capacitor, C dash, it's unknown. When it is filled with the dielectric, its capacity becomes C. And you know C is equal to dielectric time air core capacitor. Now, C is equal to K into C dash. Question is, what is C dash? Now, C dash is equal to C by K. C, dielectric capacity with the dielectric. C is the capacity, C is capacity with the dielectric. Dielectric C dash. So without a dielectric C dash, C by K. What is C? C is given to you. By with the dielectric constant is 1.5. Dielectric medium is 1.5. Has got capacity C. But therefore, C dash is equal to C by 1.5 is equal to 2 by 3C. So C dash is equal to 2 by 3C. So option is C. Next, when n identical cells are connected in parallel, they give you. Where we prefer parallel connection. Parallel connection is preferred to draw more current, or we can increase current capacity, provided they have got larger internal resistance. A parallel combination is preferred to increase current capacity for cells having larger internal resistance. Therefore, when n identical cells are connected in parallel, they give you more current. ഒരു ഡാറ്റ കൂടെ അവിടെ പറയേണ്ടായിരുന്നു, അത് ഐഡിയൽ സെല്ലല്ല, having internal resistance. If there is a larger internal resistance and to draw more current, they must be connected in. Okay. Therefore, current we can draw more current. പോരായിൻ്റെ ക്വസ്റ്റിന് പ്രാക്ടിക്കൽ സെല്ലായിരിക്കണം, internal resistance ഉണ്ടായിരിക്കണം. എങ്കിൽ we can draw more current when they are connected in parallel. And the data through these are the cells connected in parallel. N number of them are connected in parallel. Now what is the net EMF? E internal resistance R. E internal resistance R. E internal resistance R. And the N number. Net EMF is E. And I. By total resistance. External resistance connected is equal to capital R. And what is the total internal resistance of all of them? R, n number of them connected in parallel. It's equal to n by R. R plus, that is the current. It's equal to NE by NR plus R. NR plus R. This is the equation. Now you got. Take this up. And you can say that now if internal resistance is large compared to external resistance, this term can be neglected. And there was basically N into E by R. Where E by R is the current from one cell. N into E by R, that means we can increase the current capacity, provided they have got larger internal resistance. Okay. Next question. Resistivity of a conductor increases. Now resistivity rho, formula you may remember. M by N is squared to 2. The resistivity can be increased by reducing 2. Correct. How we can increase 2? Increase in temperature. When temperature increases, the relaxation time decreases. And resistivity and hence resistance increases with the temperature. Therefore, by increasing its temperature. Option is E. We shall go to our next question. Kirchhoff junction rule is based on conservation of. You know, in a junction, what is the Kirchhoff junction rule of first law? KCL, Kirchhoff current law says, ultimately sum of current meeting is 0. That means incoming charge and outgoing charge must be same, so that a junction cannot store charge. And therefore, definitely that based on what? Conservation of charge. Whereas Kirchhoff voltage law, second law, loop rule, there EMF energy generated and PD supplied, energy supplied, generated and supplied must be the same. And that based on energy conservation. Kirchhoff's second law based on energy conservation, whereas Kirchhoff's first law based on charge conservation. So our answer is charge conservation. Now that finishes our unit 5 of this, and that is today's session. Tomorrow we have to meet with the questions again from our next unit 6. Now go through that topics. Our topic and see formulas are there, and try to remember or keep that formula with you so that we can easily go through that. See you tomorrow. Thank you.